All right, so we're going to work through example 7 on page 178. Go ahead and follow along with me. While out fishing on a lake one summer afternoon, Amy spots a large trout just below the surface of the water at an angle of 60 degrees to the vertical. And she tries to scoop it out of the water with her net. So don't worry about, it says draw the fish where Amy sees it. She's going to see it right here, but we know it's not there. Water is more dense than air, so here's the normal. It's perpendicular to our medium. As the light enters from the air into the water, our index of refraction is going to be much higher in the water. It's going to be bent towards the normal. So that fish is going to appear way out here, but it's actually going to be a lot closer to the normal than what it appears to be. So it's asking at what angle should Amy aim for the fish to scoop it out of the water. If she scoops here, aims here, she's going to miss it. We got to figure out what that angle is. So Amy's going to sit down real quick and she's going to figure out what that angle is. So before she actually tries to scoop it. So it gives us index of refraction for water. N for water is 1.33. So, and then we're going to set up and use our equation. Our original equation is our N1 sine theta 1 equals N2 sine theta 2. And our N1, we can just list our variables right here real quick. Our N1, and it doesn't matter which one we assign these to, we have to just make sure if we assign N1 as the water, then we have to make sure that we assign that unknown angle to that as well. So I'm going to assign N1 as the water, which is 1.33. I'll just label that as the water. Our N2 is going to be our index of refraction for the air, which again, we mentioned in the previous problem, that was 1.00 for air. Our theta 2 that goes with the air is going to be our 60 degrees with 3 sig figs. Our unknown is our theta 1. Right here, theta 1, theta 2. It's got a goof up in the book goofed up. The book gave theta 2 and then theta 2. Hopefully you see that. So let's just assign it to, so our unknown is going to be theta 1 is going to be our unknown. Okay, so we're good. So we're going to use our initial equation. I'm going to erase these. We're going to come back to our initial equation. And we want to solve for what this angle is. So we're going to divide by N1 to get this over here. So divide by N1, divide this side by N1. We're left with sine theta 1 equals N2 sine theta 2 over N1. Okay? So we can go ahead and plug in our numbers here. We have sine theta 1 equals N2 was 1.00. Sine, put that in parentheses, sine, and then our theta 2 was going to be 60 degrees, 3 sig figs. That's going to be over N1, which was the index of refraction for water, which was 1.33. When we do the math on this, we're going to get sine theta 1 is equal to, and then we do the math right here, we get 0.651 to 3 sig figs, okay? And then we want to figure out what this angle is, so we're just going to take the inverse of sine times that 0.651. So take the inverse, so our theta 1 is going to be equal to the inverse of sine times 0.651, okay? And we're gonna go to 3 sig figs. When you punch that in the calculator, inverse of sine times 0.651, you get an angle of 40.6 degrees, which is where Amy would wanna aim for that. So, and I already gave that to you right there, actually. Very close to 40. So, N1 sine theta 1, N2 sine theta 2. It doesn't matter which one we assign these N1, whether N1 is air, N2 is air, or water, whichever one you do assign, make sure that you match up that angle with it as well. So, we're not going to do number 8, example problem number 8. That deals with that critical angle where all the light's refracted back into the object itself. What I'd like you to do is exercises for today. Exercises 9, 10, 11, and 12 from page 179 and 180. Do those 4 problems. Try to get those done before Wednesday. By Wednesday, I'll post a few videos over how to do those 4 problems so you can check your work. Or I will take pictures and post them online for you.